The example problems are provided for practice in relevant calculations. You should attempt to calculate the answer before viewing how to calculate the answer, or view what the answers are. If you do not calculate the answer before viewing the portion of the video showing the answers, you will not learn and understand the calculations sufficiently to perform well on the exam. You will not learn to ride a bike by watching a video. You have to do the calculations. If you cannot perform the calculations that are shown, you will have difficulty passing the exam. The road project starts at road station 86 plus 01.23. The road project will be 1100.41 feet long. What is the station at the end of the road project? The answer is determined by taking the road station, adding the distance, and converting the sum to a station. The diagram shows the profile view of a portion of a road. The starting station and starting grade elevation are given. The ending station and ending grade elevation are given. What is the horizontal distance of this portion of the road? The starting station is subtracted from the ending station. The horizontal distance is the difference between the two stations. What is the vertical rise between the beginning station and end station for the portion of the road that is shown in the diagram? The vertical rise or distance is calculated by taking the ending elevation and subtracting the starting elevation to result in the difference between the two elevations. What is the slope expressed as a ratio for the portion of the road previously shown? In simple terms, the ratio is the vertical distance to the horizontal distance. Therefore, the vertical distance obtained from the previous problem is displayed versus the horizontal distance obtained from the second problem. However, convention requires that the vertical distance be expressed as a1. Therefore, the vertical distance is divided by itself to result in a 1. Convention requires that dividing the vertical distance by itself requires dividing the horizontal distance by the vertical distance. The result is the reduced ratio. What is the slope expressed in decimal format? The decimal form of the slope is found by taking the vertical distance divided by the horizontal distance. What is the slope of the grade expressed as a percentage? The percent slope is determined by multiplying the decimal slope by 100. What is the slope of the grade expressed as a vertical angle? The vertical angle of the slope is determined by taking the arctangent of the decimal slope. The resulting answer in degrees and decimal parts of a degree is converted to degrees, minutes, and seconds. What is the zenith angle of the grade slope? Since the slope is positive, the vertical angle is subtracted from 90 degrees to calculate the zenith angle. In the table that is shown, fill in the equivalent slopes found in the same row as the one slope that is provided in red numbers. There will be two tables to illustrate the answers. The first table shows the conversions and formulas to determine the answers. The second table shows the answers. Starting on the first row and first column where the slope is expressed as a ratio, the decimal equivalent is found by dividing the larger number into the smaller number, or the horizontal distance into the vertical distance. The percent equivalent slope is found by multiplying the decimal slope by 100. The vertical angle is found by taking the arctangent of the decimal value of the slope. The angle is displayed as degrees, minutes, and seconds. The zenith angle is found by subtracting the vertical angle from 90 degrees. Starting at the bottom row, last column, and working to the left, the vertical angle from the zenith angle is determined by subtracting the zenith angle from 90 degrees. The percent slope is found from the vertical angle by taking the tangent of the vertical angle. This gives the decimal equivalent slope. Multiplying the decimal equivalent slope by 100 gives the percent slope. The ratio slope is determined by taking the percent slope and equating that to 100 feet of horizontal distance. Converting the ratio to a unit value for the vertical distance requires the vertical distance be divided by itself to give a 1 for the vertical distance, and dividing the same vertical distance into the horizontal distance, in this case 100, to give the revised horizontal distance equivalent to a vertical distance of 1. All values are rounded to the nearest whole number. At station 1 plus 50, the elevation is 426.21 feet. The road has a negative 3% slope. What is the elevation at station 4 plus 80? The first step is to determine the horizontal distance. The horizontal distance is determined by subtracting the beginning station number from the ending station number. The drop in elevation, given as a percentage, is calculated by dividing the percent slope by 100, converting to a decimal slope, then multiplying the decimal slope by the horizontal distance. This calculation gives the drop in elevation in feet. The final elevation is calculated by adding the negative drop in slope to the starting elevation. The following information will be used in the questions that follow. The width of the road in cut and fill is given. The side slopes for cut and fill are shown. The benchmark elevation is provided. The design elevation for the station is given. The laser level is set up. The level rod is held on the benchmark, and a reading of 4.65 feet is obtained from the rod using the laser level. What is the height of the instrument? The height of instrument is calculated by adding the rod reading to the benchmark elevation. What is the grade rod for station 14 plus 75? The grade rod is determined by subtracting the design elevation or grade from the height of instrument. Going to the center of the road, the level rod is placed at the ground by the stake. A rod reading of 2.2 was obtained. What should be entered into the field book? Since the rod reading is more than the grade rod, a fill is required. The amount of fill is determined by obtaining the difference between the grade rod and rod reading. Since the rod is held in the center of the road, the lower number is 0.0, indicating there is no offset from the center of the road. How far up from the ground should the stake be marked to indicate a whole number for the center of the road? Since the fill required is within the length of the stake, the required fill is measured up from the ground, 0.2 feet. Should the stake be marked as grade, cut, or fill? Since only 0.2 feet of fill is required at this location and the stake can be marked at 0.2 feet, the stake should be marked G for grade. How far to the left of center should be measured to place the stake for the left edge of the road? Since the width of the road in fill is 20 feet, 1/2 the distance of 20 feet should be measured to the left. In other words, 10 feet should be measured to the left. After placing the stake in the ground, a rod reading is obtained on the ground at the stake. The rod reading is 1.9. What information should be placed in the field book? No information should be placed in the field book. The rod reading is less than the grade rod, indicating a cut is now required. The stake must be repositioned by measuring from the center of the road 1/2 the width of the cut. After remeasuring from the center of the road and repositioning the stake for the left edge of the road, a rod reading of 1.8 is obtained. What information should be placed in the field book? The difference between the grade rod and rod reading is obtained. Since the rod reading is less than the grade rod, the difference is placed in the field book with a C notation to indicate a cut. Underneath the cut notation, the distance from the center of the road is written, in this case 1/2 the width of a road in cut. What distance should be measured from the edge of the road to locate the top of the slope? Since there is 0.2 feet in cut at the edge of the road, the side slope in cut of 1.2 is used to estimate the distance to measure. The vertical distance of 0.2 feet is multiplied by 2 to obtain the distance to measure from the edge of the road. No stake is set until a check is made. At the distance from the edge of the road, a rod reading of 1.6 is obtained, holding the rod on the ground. What information should be written in the field book? No information should be placed in the field book. The rod reading is not the same rod reading obtained at the edge of the road. The distance from the edge of the road must be remeasured based on the new rod reading. At the new location, another rod reading is obtained. After moving the rod the required distance, another rod reading is obtained. The rod reading is 1.5. What information should be written in the field book? No information should be placed in the field book. The rod reading of 1.5 is not the same rod reading of 1.6 obtained previously. The distance from the edge of the road must be remeasured based on the rod reading of 1.5 and a new rod reading taken. After moving the rod the required distance out from the edge of the road, another rod reading is obtained. The rod reading is 1.5, the same as the previous rod reading. What information should be written in the field book? Since the rod reading is less than the grade rod, a cut will be required. The difference between the grade rod and the rod reading will be the amount of cut required. This information is entered in the top toe of slope column in the top row of the 2 rows designated for the station cross-section. Underneath the cut depth, the distance from the center of the road is entered. This distance is determined by taking the difference between the rod reading and the grade rod and multiplying by the slope factor. The resulting value is added to the distance between the center of the road to the edge of the road. How far up from the ground should the stake be marked to indicate a whole number? Since there is a cut of 0.5 feet from the ground level, measuring 0.5 feet above the ground will result in a whole number. A line is drawn at 0.5 above the ground. How should the stake be marked? Since the line marked on the stake is 1 foot above the grade, the stake should be marked C1 to indicate a cut of 1 foot down from the mark. The right edge of the road must be located. 1/2 the width of the road in fill, or 10 feet, is measured from the center of the road. A stake is placed in the ground. A rod reading of 2.6 is obtained with the rod placed on the ground next to the stake. What information should be placed in the field book? In the field book, under the column for the right edge of the road, in the second row of the 2 rows designated for the cross section, the distance from the center of the road is entered along with the letter R to indicate the distance is to the right of the center of the road. Since the rod reading is larger than the grade rod, the right edge of the road is in fill. An F is placed under the column for the right edge of the road in the first row of the 2 rows designated for the cross section. The difference between the rod reading and the grade rod is the amount of fill. The amount of fill is placed next to the letter F. How far up from the ground should the stake be marked to indicate a whole number? Since the grade is 0.6 feet above the ground at this location, 0.6 feet above the ground should be measured and a horizontal line placed at this location. Should the stake be marked as grade, cut, or fill? Since the line is at the grade elevation, a G for grade should be placed on the stake. What distance should be measured from the edge of the road to locate the toe of the slope? To determine the distance, the fill slope is obtained from the road specifications. At a 3-to-1 slope, for every foot of fill, there is 3 feet of horizontal distance. Accordingly, the fill at the edge of the road of 0.6 feet is multiplied by 3 to obtain the estimated distance to locate the toe of the slope. No stake is set until a check is made. At the estimated distance, a rod reading of 3.1 is obtained on the ground. What information should be written in the field book? No information should be placed in the field book. The rod reading is not the same rod reading obtained at the edge of the road. The distance from the edge of the road must be recalculated, remeasured, and a new rod reading taken. To determine the new distance to measure, the grade rod is subtracted from the rod reading of 3.1 to determine the amount of fill at this location. The fill is multiplied by the slope factor to obtain the distance from the edge of the road to determine where to place the rod for another rod reading. After moving the rod the required distance, another rod reading is obtained. The rod reading is 3.3 feet. What information should be written in the field book? No information should be placed in the field book. The the rod reading is not the same rod reading obtained previously. The distance from the edge of the road must be remeasured and a new rod reading taken. The grade rod is subtracted from the rod reading of 3.3 to determine the amount of fill at this location. The fill is multiplied by the slope factor to determine the distance from the edge of the road to place the rod. After moving the rod the required distance, another rod reading is obtained. The rod reading is 3.3. What information should be written in the field book? Since the rod reading of 3.3 feet is the same as the previous rod reading, the rod does not have to be moved further. The toe of the slope has been located. Since the rod reading is more than the grade rod, fill is required. An F is placed in the toe of slope column in the first row devoted to the cross section. The grade rod is subtracted from the rod reading of 3.3 to determine the amount of fill at this location. The amount of fill is placed next to the letter F. The amount of fill is multiplied by the slope factor to obtain the distance from the edge of the road. The distance from the edge of the road is added to 1/2 the width of the road to determine the distance from the center of the road. This distance from the center of the road is placed in the toe of slope column in the second row devoted to the cross section. The distance is followed by an R to indicate the distance is measured to the right of center. How far up from the ground should the stake be marked to indicate a whole number? Measuring up from the ground 1.3 feet to locate the grade places the grade line above the stake. Therefore, 0.3 feet up from the ground is measured and a horizontal line placed on the stake. How should the stake be marked? The grade is above the stake. Between the mark on the stake and the grade there is 1 foot of fill. Therefore, an F1 is written on the stake. The F stands for fill and the 1 indicates 1 foot of fill is to be made from the mark upwards. The next 3 questions will refer to the notes that are shown. The notes are for a cross section of the road at station 124 plus 50. The grade rod is 3.2. What is the width of the road in cut? The width of the road in cut is found from the notes by locating the edge of the road in cut. The lower number is the distance from the center of the road. This distance is 1/2 the width of the road in cut. Accordingly, the width of the road in cut is 30 feet in this case. What is the side slope in a fill section of the road? The side slopes are the ratio between the vertical distance and horizontal distance. Going to the notes where there is a toe of slope and fill, the vertical distance is the upper number. In this case, the upper number is 0.5. The horizontal difference is the difference in the lower numbers between the toe of the slope and the edge of the road. The difference is 1.2 feet. To convert the vertical distance of 0.5 feet into a 1, the 0.5 is divided by itself. The same division must be done with the horizontal distance. Dividing 1.2 feet by 0.5 gives 2.4. 2.4 is rounded to the nearest 0.5 increment. Therefore, the slope and fill is 2.5 to 1. What is the side slope in a cut section of the road? The side slopes are the ratio between the vertical distance and horizontal distance. Going to the notes where there is a top of slope and cut, the vertical distance is the upper number. In this case, the upper number is 1.1. The horizontal distance is the difference in the lower numbers between the top of the slope and the edge of the road. The difference is 1.6 feet. To convert the vertical distance of 1.1 feet into a 1, the 1.1 feet of vertical distance is divided by itself. The same division must be done with the horizontal distance. Dividing 1.6 feet by 1.1 and rounded to the nearest 0.5 gives 1.5 to 1. The next three questions refer to the following situation. There is one surviving stake marking the right toe top of the slope for the road. The bottom of the rod is held at the mark on the stake. A rod reading of 3.8 is obtained while holding the bottom of the rod on the mark on the stake. If the stake is marked F3, what is the grade rod? Imagine the bottom of the rod being raised from the mark 3 feet above the mark to reach the grade line. The grade rod is equal to 0.8 in this case. What if the stake is marked C2 for cut 2 feet when the rod is held on the mark on the rod? What is the grade rod? Imagine the bottom of the rod being pushed into the ground 2 feet below the mark until the bottom of the rod was at grade. The reading with the bottom of the rod on grade is the grade rod. The grade rod is equal to 5.8 feet. If the surviving top of slope stake is marked C2 for cut 2 feet, the side slope in cut is 2 to 1, and the width of the road in cut is 33 feet, what would be the field book annotation for the top of the slope if the distance from the ground to the mark on the stake is 0.3 feet? The grade is 2 feet below the mark. If the ground is 0.3 feet below the mark, the distance remaining from the ground to the grade is 1.7 feet. Accordingly, the field book will show a cut of 1.7 feet at the top of slope. At a 2 to 1 slope, the distance from the top of the slope to the edge of the road is determined by multiplying 1.7 by 2. The result of this multiplication is added to 1/2 the width of the road to obtain the distance from the center of the road to the top of the slope. How far from the center of the road is the transition point between cut and fill located for the following situation? The transition point is determined by taking the total horizontal distance divided by the total vertical distance times the partial vertical distance. The total horizontal distance is the distance between the center of the road and the edge of the road. The distance is the lower number under the edge of the road column. The total vertical distance is the sum of the vertical distance in cut at the center of the road and the vertical distance of the fill at the edge of the road. The partial vertical distance is the cut distance at the center of the road. The result from the division and multiplication is the distance measured from the center of the road toward the edge of the road where the transition point occurs. How far from the edge of the road is the point of intercept of the side slope with the ground slope in the situation that is shown in the diagram? The first step to determine the point of intersection is to determine the slope of the ground from the center of the road to the point of elevation at the right. The ground slope is equal to the difference in elevation divided by the horizontal distance. 3 equations are written. In the first equation, the elevation at the point of intersect along the ground slope from the center of the road is written in the format of the starting elevation plus the horizontal distance times the slope. The starting elevation is known. The slope was calculated. The variable x will be used to represent the horizontal distance from the center of the road to the point of intersection. In the second equation, the elevation at the point of intersection is determined by starting at the road edge, then going along the fill slope. The equation is written in the format of starting elevation plus the horizontal distance times the slope. The starting elevation is known. It is the grade of the road. The slope is the fill slope. The variable y will be used for the horizontal distance. Since both equations equal the elevation of the point of intersection, the equations are set equal to each other, reducing two equations into one equation. The one equation has two unknowns. Therefore, another equation is required. The third equation is determined by realizing that the y distance subtracted from the x distance must equal 1/2 the width of the road. The equation is manipulated to isolate the x value. The equation is substituted into the earlier equation for the x value. Parenthetical portion is eliminated. The variable y is placed on one side of the equation, the constants on the other side of the equation. The y variable is isolated. The variable y is calculated. This is the distance from the edge of the road to the point of intersection. The variable x can be calculated by substituting the y value into an earlier equation and solving for x. A check is made by taking the two equations used earlier to determine the elevation of the intersect. The x values is inserted into the one equation and the elevation of the intersect calculated. The y value is inserted into the other equation and the elevation of the intersect calculated. The elevations are the same. The check is completed. Given the topographic information, location of the building, grade of the building, and side slopes of 3:1, where is the approximate edge of the cut and fill? The grade elevation intercept within the building is determined. The depth of cut or fill at each corner is determined by calculating the difference between the grade and ground elevation. This depth of cut or fill is then multiplied by the slope at each corner. The distance is scaled out from the corners of the building to determine the extent of cut and fill. A line is drawn connecting the fills. A line is drawn connecting the cuts. The cut and fills are labeled. To give credit where credit is due, many of the images used in this video were licensed from Shutterstock. The images are available from shutterstock.com.